Hey everyone, and welcome. This explainer is brought to you by Rooted Layers, where we're all about AI insights that are grounded in solid, verifiable research. You know, we are right on the verge of a massive shift in how we work with AI. Seriously, we're moving away from just typing in commands and getting back answers. We're heading towards something that feels a lot more like a real partnership. Think of it as going from just using a tool to having a true co-pilot, one that can reason through problems on a scale we've never even dreamed of tackling before. But to get there, we have to solve one really fundamental problem first.
So just imagine for a second, what if you could ask an AI a super complex question, and to answer it, it could instantly read and understand every single relevant book in an entire library? The kind of answers you could get would be incredible, right? It sounds a little like science fiction, and for most AI models today, well, it is.
And the reason why is actually pretty simple. Most of these large language models have a really limited short-term memory. It's something we call the context window. It's kind of like trying to read a whole epic novel by looking at it one sentence at a time through a tiny keyhole. The model just can't see the big picture. It can't hold a massive code base or a whole library's worth of books in its head all at once to reason about it. But what if we could just smash that barrier? There's a new technique that lets models process a mind-boggling number of tokens. We are talking about up to 11 million of them. Now, to give you some perspective, that is almost 100 times bigger than what even a really large top-of-the-line context window can handle today. This isn't just a small step up, it's a total game changer. So how on earth is this even possible? Well, the secret is in a totally new approach called Recursive Language Models, or RLMs for short. The idea isn't to make the AI's memory bigger, it's to make the AI smarter about how it uses the memory it has. It's about letting the model literally program its own thinking. Okay, so this is the crucial insight. Instead of trying to shove that whole library through the tiny keyhole, an RLM treats the library, your big prompt, like it's an object in a room that it can walk around in. It doesn't try to read everything at once, no way. Instead, it writes and runs its own code to interact with the data. It can write a script to find keywords, a function to summarize chapters, or another one to compare arguments, all without ever needing to hold the whole library in its memory. Now, this idea didn't just appear out of nowhere. It builds on a lot of previous work, but it takes this huge leap forward. See, older methods tried to give the AI a better map or smarter tools, but they all ran into this same wall. The initial problem, the whole big prompt, had to fit inside the AI's memory just to get started. The RLM is the first to actually solve this input scaling problem. It's the first to let an AI tackle a problem that is, right from the get-go, way bigger than its own memory. But of course, this incredible new power creates an equally big, new problem. If we let the model program its own thinking, how do we see what it's actually thinking? We've given it all this autonomy, but in the process, we've kind of created a black box. And this black box introduces all these new and subtle ways for things to go wrong. The model might write a little search filter that accidentally skips over the most critical document, or it could decide to split a paragraph right in the middle, totally breaking the meaning. A little subtask it creates could just make something up. Or even worse, its entire strategy for solving the problem could be totally wrong from the very beginning. And because the AI made these calls on its own, good luck trying to debug that.
It's the essential question, isn't it? We've given this thing this amazing power to navigate through oceans of information on its own. But what happens when it makes a wrong turn? How do we possibly get it back on track?
Well, the solution is just brilliant. It's not about trying to see inside the black box. It's about getting inside it with the AI. The answer is to pull the RLM out of its isolated little world and drop it into a shared environment that developers already know and love, the Jupyter Notebook. We're not just opening the black box, we're turning it into a shared cockpit.
This, right here, is the real aha moment. The old way, the model works over there in its own little sandbox. The new way, the human and the model are sharing the exact same digital workspace, the same kernel, the same variables, the same memory. That wall that used to be between the user and the model, it's just gone.
The researchers who came up with this have the perfect way to describe it. It's not about sending prompts back and forth anymore. It is, and I'm quoting them here, pair programming on a shared heap. You and the AI are literally coding together, in real time, working on the exact same stuff.
So here's what that new collaborative loop actually looks like. First, the model comes up with a plan and starts running its code. Second, you, the human, can see a step-by-step trace of its thinking right there on your screen. Third, and this is the magic part, if you spot a mistake, you can just hit pause, go right in and change the variable or fix the logic, and then Fourth, you just let it continue running, now with your correction baked right in. You actually become the co-pilot, making these little surgical fixes whenever they're needed.
So yeah, this opens up a whole new collaborative frontier. It's truly exciting stuff. But with any brand new technology, it's really important to be realistic about what it can do right now and where it still has a ways to go.
Okay, so let's be super clear about what this isn't. It's a really clever framework, a scaffold, but it doesn't actually make the base AI model any smarter. Right now, it can't really do deep, multi-level recursive thinking. And sharing a workspace like this, well, it brings up some security risks you have to be careful about. Plus, because the AI is deciding how much code to run, complex problems can get pretty expensive fast. And maybe most importantly, even with all this new visibility, the model's high-level strategy can still be just plain wrong.
But even with all those limitations, the fundamental takeaway here is huge. For the very first time, the tools are actually in place to completely change our relationship with AI. We're moving past the simple model of giving instructions and getting back an answer. We are really truly entering an era of collaboration.
So we're at this fascinating point. The technology to turn a block box into a glass cockpit, to turn an operator into a co-pilot, it's here. It exists. The only question left is the human one. Are we ready to climb into that cockpit and learn how to fly together?